Hi, this is Jason Molesky. In this example, we'll use some Minitab output to perform a significance test for beta. Infants who cry easily may be more easily stimulated than others. This might be a sign of higher IQ. Child development researchers explored the relationship between the crying of infants 4 to 10 days old and their later IQ test scores. A snap of a rubber band on the sole of the foot caused the infants to cry. The researchers recorded the crying and measured its intensity by the number of peaks in the most active 20 seconds. They later measured the children's IQ at age 3 years using the Stanford Binet IQ test. Now a scatter plot and the Minitab output are shown here, and we can see in the scatter plot that we do have somewhat of an upward linear trend in the data. Count of crying peaks, as that increases, it does appear IQ increases as well. Our Minitab output will come in handy for performing our test. So to start with, let's look at the equation of the least squares regression line for predicting IQ at age 3 from the number of crying peaks. Then we'll interpret the slope and y-intercept in context. Well, from the Minitab output, the equation of the least squares regression line is predicted IQ score equals 91.268 plus 1.4929 times the cry count. Now what that means is for each additional crying peak in the most active 20 seconds, the regression line predicts an increase of about 1.5 IQ points. That 1.5 again comes from the slope. Now the y-intercept in this case is about 91.3, and what that means is the model predicts that an infant who doesn't cry when flicked with a rubber band will have a later IQ score of about 91. Now what does the value of S mean in this particular setting? In the Minitab output we see down here the value of S is 17.5. Well, recall that when we make a prediction with this line, we're not going to get the exact true value, so we figure the size of a typical prediction error when using the regression line is about 17.5 IQ points. Now, do these data provide convincing evidence of a positive linear relationship between those crying counts and IQ in the population of infants? Well, we'll want to perform a test of the null hypothesis where the slope is 0 against the alternative hypothesis where the slope is greater than 0. Where beta is the true slope of the population regression line relating crying count to IQ score. Since no significance level is given, we'll use our standard alpha equals 0.05. Now, if the conditions are met, we'll do a t-test for the slope beta. Checking our conditions, again using the linear acronym, linear, the scatter plot suggests a moderately weak positive linear relationship between the crying peaks and IQ, as we saw in an earlier slide. The residual plot shows a random scatter of points about the residual equals 0 line, so our linear condition is met. For independence, due to sampling without replacement, there have to be at least 380 infants in the population, 10 times our sample size. Well, that seems reasonable to assume in this case, so independence is met. For the normal probability plot, we note that the residuals show a slight curvature, but no strong skewness or obvious outliers that would prevent the use of t-procedures, so our normal condition is met. And finally, for equal standard deviations, we note the residual plot shows a fairly equal amount of scatter around the horizontal line at 0 for all our x values. And we are told that the 38 infants were randomly selected. So our conditions are met, and we can go ahead and proceed with a t-test for beta. We can get the test statistic and p-value directly from the Minitab output. The t for cry count in this case is 3.07. And the p-value, as noted here, is 0.004. Now, that's the p-value for a two-sided test. Minitab always gives that in two-sided form. Since we're performing a one-sided test, our alternative is just that beta is greater than 0. We have to divide that by 2. It's half as much, or 0.002. Now, because the p-value 0.002 is less than alpha equals 0.05, we reject the null hypothesis. There is convincing evidence of a positive linear relationship between intensity of crying and IQ score in the population of infants. For some additional practice with the significance test for beta, try exercise 13.